your browser is a smart piece of software that you use for a lot of things. I would argue that the browser is the most popular platform for publishing software on. Does this make sense? What I mean is the subject of this class, should you do more, are more apps made to run on iOS or Android or the web? The answer is the web. So the software that supports that is the web browser. And even though I haven't told you much about it before now, your browser does more than just render HTML and CSS and make the pretty styles look pretty on your page. It also is this virtual computer that can execute JavaScript code. That JavaScript code, though, can do more than just run ifs and loops. It can integrate into the important objects, the important state that your browser is maintaining. Specifically, these three things. So these three things, the browser object model, the document object model, and some global JavaScript objects are built into your browser, and you can program with them in JavaScript. And that's what really gives you the ability to do all kinds of fanciness in JavaScript because you can integrate into the pages. So maybe on some sense, you already knew this because we've already been doing document.querySelector and changing the page based on the code that we ran. So the browser object model, which is apparently actually called the BOM, really encapsulates everything that's in your window except the document. The document is almost like the most important thing, so it gets its own thing, the DOM, the document object model. So this is really the most important thing, I would say, the document object model, and perhaps you've already seen the idea of the DOM come up. But in JavaScript, we can access the history. So that's like all the stuff that would be in your back button or forward button, you could programmatically access in JavaScript. We can get the location, which is all the stuff that's in the little URL bar. You can read or write to or from that. We can navigate, that is, we can follow links. And we can get all kinds of information about the screen. Like if you actually want to know about the screen dimensions of the user's device, not the browser, window dimensions, which you could also get too, but the actual screen, you could do that. So that's just a really brief overview of the browser object model. So basically there are objects that have like history dot or location dot. I want to say it's like location.url, where you could program with these objects, and these objects have properties, and you could read or write to from them, okay? The biggest part is this middle thing, and I have this really simple, super vanilla Microsoft Word art thingy, which shows you the idea that this document object model has this hierarchical structure. If you've taken data structures, can you tell me what kind of data structure this is? That's a tree. That is a tree. How'd you know it was a tree, JT? It has a root. And yeah, and what are these here at the bottom? They're leaves, yeah. So the inherent structure of a web page is a tree because there is a document which contains HTML, which has head and body. I would put some stuff in the head like the title and maybe some other stuff that's not that important. The body has a bunch of elements underneath it. That's our document object model. What JavaScript allows us to do is to search that document object model, to add nodes, remove nodes, edit the content of nodes. When we change the document object model, the web page changes. So this is how we can get dynamic web pages. So if you've ever been on what is it you're into? I don't know. If you've ever been in Gmail, you guys know Gmail? It's like this Discord-esque communication mechanism where it's more difficult to receive real-time messages. Gmail, the mail app. So you know if you're ever in Gmail, you can receive an email while you're just sitting there doing nothing, and it'll pop up and say, whoa, you got a new email right here. How did that new piece of content come onto your browser? It's because there was JavaScript executing in the background that was both checking the server, and when it found there was a new message, it changed the web page without you having to refresh. There's also a bunch of built-in JavaScript objects that help us do stuff that we don't want to code ourselves, like all kinds of string manipulation, number manipulation, math, regular expression, all kinds of junk, dates that you don't want to code yourself. In my mind, these are kind of like the standard library. Okay, so here's a couple of, just a little bit, one slide explaining the BOM. So these, the browser object model are some additional objects provided by the browser for working with stuff that's not the document, like the window size, the URL, the browser info. So yeah, so you could, if you want to get exactly what kind of browser this is, the specific version of Chrome, we could get that out. So here's some examples over there where window.innerHeight is the inner height of the window. We can get the window.location.href to get the current URL that we're on. You can automatically navigate back. That does, on the whole, feel like a way to just prank your friends. Like, say, go to this website, and then it goes back to the previous page, and then say, tell me to go forward. This would be the name of your, I don't know what code name is of the user's browser. So there's a lot of stuff here, and if you need this stuff, this would be the only way of accessing it in JavaScript. But to me, it's kind of less important for day-to-day. On the whole, this would be I would Google, how do I do this? How do I get to the URL, change the URL in JavaScript, and then learn from Google or ChatGPT how to do that. This isn't rocket science. The document object model is where we're going to spend more of our time, because this is what allows us to actually make dynamic web pages. So the document is a tree structure where each node represents an object in the document. And what we can do in JavaScript is access these elements. We can traverse the tree. So if we want to find, I don't know, the anchor tag that is a sibling to an H1 tag, that is the second H1 tag on the page, we can do that programmatically. We can also modify this tree and actually make changes to the page. So we can make it so that the page that the user sees is not the page that they loaded from our web server. We're going to generate a new version of the page by adding, removing, or editing the nodes that are on that tree. So summing this up again, I kind of already just said this, but JavaScript can change, add, remove to the HTML. It can change, add, remove to the CSS. We can also react to events and create new events that happen on the page. I'm going to drop this on you, but I don't want to spend too much time here because it's boring. But there are many ways of finding specific elements so that you can do something with them. We have generally, I think, just used the get element by ID. But you can also do the query selector. So if you do get element by ID, you have to pass in an ID. What if you want to be more flexible than that? So you can say query selector and pass in any CSS query selector. So this would be a list item that has the class of Stanley. So this would return the first match on the page to the first list item that has the class of Stanley. These two methods here, get element by ID and query selector, return one and only one element. I guess they could return none if there's no match. There are other times when you'd like to return many elements and then potentially process all the elements. So that's what these methods do. You can say get elements by class name. Notice the S here. So I'm looking for all the elements that have a class of card. And note that this is going to return an array of elements, not one. So even if you just expect one, you've got to get the first thing out of the array if you use one of these. So it looks like you can also pass by tag name. So this would get all the LIs. Query selector all is the most general, but apparently it's a little bit slower than this. If this is actually what you want, it's just class name. But in this case, this query selector all is saying, get all the anchor tags that are on things that have a class of card, and it'll pull all those in a list. So that's kind of equivalent to the query selector, but it returns multiple things. So this is how these are 5 different ways of finding things on the page. Why are we finding things on the page? I don't know. Because we want to do the next thing, which is change them in some way. I don't know, maybe this goes between them. We can also traverse the DOM. So if you wanted to say, hey, find me the thing that is a card, the first anchor tag that's on a card, and then go to whatever is the next sibling underneath that. Basically, the siblings are like at the same level. You can do that with the DOM. So you see this next sibling, first child. You can basically move in all these directions. You can go up to your parent node. You can go backwards to the previous sibling, forward to the next sibling. You can go down to the first child, the last child, or you can traverse the child nodes, which would be an array of all of the children, right? So hierarchically in the tree, that would be all of your children. Does this make sense? I get why this maybe seemed disconnected if you've never needed to find something like that, but there are situations where you want to, like, I guess you don't know your structure absolutely, so you need to say, oh, actually, whatever the user clicked on, go up 3 nodes, and that's the thing that I actually want to change now. Can you imagine that? Like you click on one thing, and that's, if you, like that's the link, but you want to actually know the container of the container of the thing that they clicked on, and then you want to add some CSS or HTML on that. You could do that with this traversal.
Now, does that stuff that's been hidden?
Yeah. So hidden, I'm 99% sure.
I'm guessing if you've done it like
yeah, because it's
100%.
yeah, it's like hidden really is just CSS. This isn't respecting CSS at all. Good question. This last thing, which this is second to last thing, we have looked at, which is how do you change content dynamically? You have to find the thing, and then on the thing that you found, which is some kind of element, which is really a node, it's a node in this tree, you can access the text content or the inner HTML content. If you want to just change the text, then go with text content. If you want to actually change it to be a different kind of HTML element, or to like actually add something, well, that wouldn't be it. That would be changing the, if you want to change it to be a different HTML element, then you have to use inner HTML. You can't, if you put this onto text content, it'll just show this up like in plain text on the page. You with me? It wouldn't actually add a new anchor tag down here unless you use inner HTML. So what I'm trying to show you here is if this is what was on the HTML that we wrote, when we execute this code, it would actually then change the logo to have the inner HTML of home.html and home all caps. You see how we like actually replaced this text with this text. And it wasn't just plain old text, it was an HTML node. In addition to modifying what's there with that inner text and inner HTML, text content and inner HTML. You can also create and remove elements but it is a pain, in my opinion. So you have to say create element and pass in the kind of element you want to make to create a node. Okay, so at this point, we've created an element that is a list item element. In order to put content into it, we have to create another kind of node, a text node, and then we have to append the text node to the element. So it takes all these steps. And then what I end up doing here is I take this li, I find the first UL, the 0th UL that's on the page, and then append this element. What is this element? It's a list item, but this list item element has a text node inside of it. So this is what it would take to put a new list item with text onto a UL, an existing UL, programmatically. It takes, those 5-ish steps. We could probably consolidate that a little bit. Do you see how verbose this is and kind of error prone? If you're actually adding new content to the page, to me, it's not as simple as one would want. Questions on this element creation? There would be an equivalent kind of element removal, but that would probably be pretty easy because you don't have to create a text node to delete it. You would just find the one you want to delete. I'm pretty sure it would be like remove element or remove node. But you got to find the one that you want first. This is just an homage to, there are those other JavaScript objects like dates and strings that you can do stuff with that is built into JavaScript. And this is kind of where they would be in this global JavaScript area. Okay, so doing two things here is, one, I want you to see how JavaScript allows you to do all the things that you can do to a web page to make it dynamic. And two, I'm intentionally showing you that this is a pain in the bottom. And this is not, you don't have to go very far before you realize I cannot manage the complexity of a large scale, medium scale app with this interface. It just begins to break down. And people 15 years ago, really probably since almost forever, have thought, I don't want to write this much JavaScript. This is too much work. I'm going to write a JavaScript library, a JavaScript framework that does a lot of this work for me so that if I want to add a new node, I can more easily do it than going through this interface. And React is now the most popular way of achieving this kind of speed up, of abstracting away the complexity. So I wanted to throw out just a couple of ideas as to why people use React. You've already watched some videos, and maybe you've heard this. Why React? And I'm going to make these slides up as I go. I almost made Emily do it because she's so good at this. You remember that time when we did that in class? It was fun, wasn't it? Okay. Why React? Okay, I'm going to say that all of this is under the umbrella of, because we want to make complicated things, and regular plain old JavaScript doesn't allow us to do that without just being crushed under the complexity. And we end up having to create what lots of people call spaghetti code, where this thing jumps around to here, which jumps around to here. If you can imagine, in an interface where you've got, when this thing changes, when the state changes, then this thing changes on the screen. But when this thing changes on the screen, I also need this thing to change on the screen. But also when this thing changes, this other thing changes. It's not unreasonable to have that kind of all these things need to kind of stay synchronized. And when you change one, they all change. For example, in your Gmail app, if you can kind of imagine, maybe it's not Gmail, it's something else. But when we get a new email, then we need to show that there's a new notification like maybe let's do Facebook. You know, the Facebook, well, it doesn't matter if it's the web app or the mobile app. But when you get a notification that somebody liked your thing, then that changes something up here. In the upper right, where we get a little red area, that number changes to a 1. But also, if you were seeing the screen right then, it should also have been the case that the count on your number of likes or replies just went up as well. And if you were on that screen, you may expect it to just load in the new comment. Let's say it was a comment that came in. Does that make sense? So because of one action that somebody else took, like 3 or 4 different spots of your screen needed to be changed and updated. Does that make sense? And the old school way is really error prone and complex to say, I want to change this and that and this. So all this is under the heading of to abstract the complexity. So let's say this one. All right. So one big reason to use React is to simplify DOM manipulation. We've seen how complex it is in the old way. With React, it's much simpler to do DOM manipulation. Specifically, what all the fancy people will say is we're able to use a declarative syntax. This syntax is JSX or TSX if you're using TypeScript. It is much easier to declare, this is what I want my thing to look like, and then we've got some embedded code, than to make everything a very procedural set of code that runs, which is what we're doing now for like async audio. But this declarative syntax, many people find much easier to deal with. So we're going to, I need a word here, simplify DOM manipulation. So the adding, the removing, the modification of the DOM is a lot easier in React. Have I mentioned Facebook made React? They made React so that they could make Facebook better because it was so complex before React. I get that none of us are making something on the scale of Facebook, the web app. But still, many people have found this useful even for smaller web apps. I want to say there's something called state synchronization. That is really close to correct. That hanging in is really hurting me. Okay. So this is really why it's called React, is because React handles the complexity of when this particular state changes. When you change some variable and it needs to update 3 or 4 different things in the UI, we put that in that declarative syntax, and we don't have to worry about finding the right nodes and then changing them on the DOM. React does that kind of legwork for us. It automatically reacts to changes in state. I think I'm going to write that. Bothers me that, there we go. The declarative syntax I'm saying is both your it's your HTML and your logic joined together, which I know we love separation of concerns, but sometimes it is different. But when you have to code all your JavaScript in one file, which is what we're doing in vanilla JavaScript, and then all your HTML in the other, sometimes you like get disconnected and forget, what did I call that thing? Whereas in React with JSX, you don't have to worry about what you called that thing because you're inside of it already. It's already gonna be linked. All right, one more. Let me mention one more advantage. There's a lot that could be said here. I think I want to emphasize components. Dallas mentioned this last week. but making reusable components, these reusable chunks of both UI and logic, is useful. So when we've made a widget that does a particular thing well, and if we happen to have more than one of those widgets on our site, we can reuse much of that. So having reusable components is huge, and something that React makes very, I don't know, first-class citizen. Like that's, if you can't avoid components. You're going to be componentized from the beginning. Even your whole app is a component composed of other components, which are composed of other components. Components, components, components. Have you guys seen the Steve Ballmer video? Anyone? Negative. Okay, we'll see that later today. Something I feel like I should mention, although you'll hear about it, is DOM manipulation, in addition to being complex to code, is slow. That is, it's slow. When you change the DOM, then the browser has to re-render the whole page. And if you do that too frequently, then it can be really, really slow. We don't like slow. Nobody likes slow. Yeah? No one likes slow. So what React did, that I watched the documentary, so I know this. Also, I do recommend the documentary on React. It's really nicely done. This seemed like overkill. Like, are you kidding me? You're going to do what? React has a complete virtual DOM, which means it's like a shadow DOM, which doesn't that sound secretive and just like, I don't know, tantalizing? So it keeps a copy of the complete DOM, and when you make changes to the DOM, you're actually making changes to the virtual DOM, which is just the DOM in memory, but you don't actually, it doesn't make changes to the web page until it's kind of resolved what the changes are to the virtual DOM. So instead of making 4 different changes, boom, 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 remember those 4 linked changes? It'll do those 4 changes on the virtual DOM and realize, oh, these 4 things need to happen. I'm making 4 changes. And when I'm done with all 4 of them here and I realize I've resolved the changes, then I'll make 1 actual change to the DOM, and then it's much faster. Does that make sense? That's my super simplified version. I have not dug into that because it sounds really gross and complicated. But I think that's the essence of it. And basically, that's what you get for free by using React. Something that nobody would have ever done before because it was so complicated. Like, why keep a virtual copy of what the browser already has? If you're going to make highly complex reactive apps performantly, then you might need to do that. And the Facebook people did it and then gave it away to everybody. So I would like to mention here that there is this virtual DOM which invisibly operates to help everything go faster, which is cool. So to sum it up, React gives us a simplicity in interacting with a complex web page by giving us JSX and a virtual DOM and this auto state synchronization. It gives us the ability to scale, to make more complex web apps because we've got reusable components, because we don't have to deal with, like, we're automatically resolving state changes and synchronizing the changes with the UI. So we're enhancing reusability. We're also enhancing performance by using that virtual DOM. All of this makes the whole system more maintainable. If you can read it easier, if you can debug it easier, if you can understand what's happening without having to trace down a complex set of spaghetti code to figure out why changing this thing changes this thing or doesn't change this thing, right? When you're like, why did it update? React provides all that. Another big reason now, which is in a different column in my book, based on this stuff, it's not inherent in and of itself, but now it is so mature and there's such a large community that you can find lots of third-party plugins and other components that people have made, that, so you don't have to make it. Then you get high productivity. So that's huge. There's also a huge learning community. There's also like the LLMs, Claude, ChatGPT, Gemini, they know React so well. And I think if you were to use some like new upstart framework, that might conceptually be better than React, which I would doubt. The LLMs wouldn't have as many examples of how to do stuff in it, which to me actually is a thing now of, oh, this isn't technically better, but my AI knows it better. So it is better for me, for business. It is a weird dynamic to me. Does that make sense? That it's not like a meritocracy of the best technical components, but like I said, it never was. Okay. Questions on this React stuff? It's kind of the why React. Okay, I'm going to show you a couple memes before we look at code. There is some more stuff that I want to show you. You're still going to have this, yeah. Semicolons are optional in JavaScript. One of the biggest complaints about JavaScript is that it is not type safe. Right? You don't have to declare data types, even though they're underneath that. That can often get you into some trouble because stuff just breaks as you're running the code, and there was no compilation to determine, wait, are you using that the way you should be using it? JavaScript is like, no, I don't care, just do whatever you want to. I'll let you know when you break something. And oftentimes you'll see stuff like this. A big response to that is TypeScript, strongly typed, inherently safe, compiled programming languages. And yet we just love JavaScript because it gives us complete flexibility, utter freedom, so that we can destroy ourselves. So TypeScript has been like one of the most popular new languages in the past 10 years. It's always in like the top 10 of the listings that I see. Correct me if I'm wrong, JT, but I think it's Stack Overflow. People love TypeScript, and we may end up, you can almost accidentally be using TypeScript because so many of the templates opt into that. The beauty of TypeScript is, I should have led with this, TypeScript is JavaScript with types. So if we put types in, TypeScript defines how to do that. And as soon as we do that, now our tooling, like VS Code in particular, can tell us you're not using that right. That's definitely an error based on what you've said the data types are. Now on the other end, as soon as you opt into TypeScript, you're going to get these new errors where the VS Code is like, no, I don't know what that is, you can't use it. You're like, no, I'm using it right, I promise. It's going to be that shape when I use it. TypeScript's like, no. You got to tell me ahead of time what shape that's going to be, like what interface or type, and then I'll let you use it. But on the whole, like even though it may seem annoying on the front end, it's worth it so that our code actually works and we have confidence in it when we're running. This is also really true of this realm, although it's been a pretty good, React's had a good streak. All these new frameworks are constantly being released. Okay, let's open up the acceleration audio. I wanted you to definitely see the sweet code that I wrote for you. Even though it looks terrible, there's a lot of examples of functionality in it. So within this, I fixed Lucide the way apparently it should be used if we're in a vanilla JavaScript kind of project. So we're getting the script from unpackage.com, and then we've got to execute this lucide.create icon. So this is the right way of doing it, the most preferred way of doing it if we're in a vanilla JavaScript project, to the best of my understanding. You can see the way to use this is we have just an italics tag and then data-lucide, and then whatever the keyword is, that's the name of that icon. So if you go to Lucide's page, and look at their icons, which they have a ton of them. Find the one that you want. Like the university icon. I'm pretty sure whatever this name is exactly, now you can click on it and copy it, but I'm pretty sure it's going to be university. And then just put in the name that you copied. And you see now I do have that university icon there. I found that with Tailwind and Lucide, this was the best way to control the size. You could just put in, you have to put in width and height. Text sizing didn't do it. And then I also found that which way was this? The text color will be the outline or the stroke, and there's a fill color that would be the fill color. I don't know another word for that. So, so in this case, you see I made the text transparent and the fill amber 600. So if I said here text red 600. Wait, why is that black? I think it should be red. I am not watching it. That's what's going on. Yep. I can't believe it changed though.
Maybe because it wasn't.
Yeah. Thanks, guys. Yeah. Thank you, Emily and JT. So that's kind of an overview of that. The way that you could style those icons. Switching to main.js, I wanted to give you an example of a couple different things. So I wanted to see if I could get play and pause and the progress bar working. I found that there is a built-in control called progress that has limited styling functionality. Where's that? I guess it's this gray thing. And then I also wanted to see if I could have a complete custom progress bar, and that's what this is, which is a div that has this light BG100 color, and then they're both height 8, so the inner progress bar is like what actually moves. And I made it BG Amber 500. I have an audio player down here. That was just so that I could see it. But what I think we're going to want to do is remove it by removing controls. And then there is that audio player on the page, but we're going to control it with our own buttons. So this is some music. Oh, that's another reason to check out this project. I put a folder here of songs. These are what I believe are open source songs from the students last year, and open source album art that goes with it. So it is, to me, important that we not put copyrighted music in a public place for people to download. That's if we're going to be sharing music, then we got to make sure we have the rights to do that. Yeah. I'm giving you freedom to do however you want, but I do think you got to have some music. I do not want this to be about, I don't want you to have to spend a bunch of time finding music if you don't want to. There's open source music you could find out there. So if you want to download these and just copy paste the songs and album art in, I do want you to have both those things. So I just put in this little data array. This is almost like the array of song objects, where every object has a file and an album art. You see they're associated together. I don't think I showed the album art. But then I set this up so the play button plays the current track. What I learned was you have to get a hook to the audio player, and then that audio player, if you change the track, you have to say load. And then it has a play and a pause. For the audio player has this time update event, which is kind of unique. Like right, other controllers don't have that. And in this event, I run this code to update the progress bar's value. Izzy? Oh, good call. This album is misspelled? Hmm. So this is a great example of JavaScript at its worst. Right? I misspelled this thing. There was no type defined, and now this is the way to spell album in this project. And if you spell it correctly, it will break. Thank you. Thank you. Notice I have this base URL as well, which this was really this should be the base URL for songs. You'd need another base URL for album art, which is in order. I concatenate these together when I use them to say, hey, get the base URL, add a slash, and then the song name, because I don't want my entire app to. I don't want to have to embed the folder name here. You could do that, but to me, then it's like, well, what if you change the folder name? The folder that it's in isn't really, to me, intrinsically defined in what this song is about. That should be movable, in my opinion. Thank you, Izzy. Yeah, clean this up. Be better than me. This was just a super simple example of how to do the acceleration. So in this case, at each of these time update events, I'm increasing the playback rate by 100th. You don't have to do it that way. You can do it whatever way you want to. I'm also here, console.logging this to see what the percentage is. And then here you can see how I'm dividing the current time by the duration, multiplying by 100 so that I can set the width equal to that. But then there is a percent at the end to make that width. Last thing I want you to see, to me this is also just, like, this isn't rocket surgery. It's just JavaScript. It's gross, but this is the way it's done. If you want to allow your app to have keyboard shortcuts, actual keyboard, hardware keyboard, then you need to add an event listener to the whole document, and key down is one of the events you can listen to. I think there's also key up and key press, I want to say, which are just slightly different times that in the key press cycle. You can take in an event. You need to take in an event object, which is the object that gets sent to this function when the event happens, because this is going to be whenever any key is pressed. So in this switch statement, I'm lowercasing the event and then checking just a couple of cases. Is it a space? If it's a space, then I'm going to play or pause depending on the opposite of whatever it's currently doing. Also on here, just in case the event should have caused something else to happen, I'm making it not happen. And then in this case, what M was for muted. So that was just like two examples. I know I didn't put those features in, I don't think. Did I? Maybe I did. No, I did when I wrote it up, because I want you to just get this example. Notice you need to have a break statement here. Otherwise, it will like fall through to the next case, which is not usually the behavior that you want. Also, I see that I put semicolons in this code and not in, well, I'll put it on a lot of the other code. Okay, to me, semicolons still feel right. I'm sorry. I grew up in the 90s, and everything was semicolon back then. So I think I had you do like a skip forward 10 seconds, skip backwards 10 seconds kind of thing. So this is acceleration audio. When is it due? Friday? You feeling good about that? Yes. We are having a quantum thing on Friday, which I haven't posted yet.
It's going to be due Friday?
Yeah. This one's easier, and I'm going to post it. Do y'all want to do it together on Wednesday afternoon? Like another code along? Would anybody be available between like 3:30 and 5? Okay, well, let's keep talking.